Hello Legacy Sabers, Marsh here. So today we're going to talk about systems of linear inequalities. What you're going to want to have on you today, your notes, and then you're going to want some graph paper today, a pencil. You're probably going to want two different pens or two different colored pencils. I recommend that highly. And then you may need a calculator, and you may want a ruler if you want to do some nice straight lines for your graphs today. Your learning target: I can graph and solve a system of inequalities. So, what are we doing? What have we been doing? A solution to a system of equations. So I have x plus y equals 10 and 2x minus 3y equals 12, and I've graphed those two equations in my coordinate plane there. Well, basically the solution is the point where the lines would intersect, right? The point xy that works in both equations. Now, what happens if I want a solution to a system of linear inequalities? So if I graph my two inequalities and I'll graph their sides. So I have them, x plus y is less than or equal to 4, and x minus 3y is greater than 8. So I will shade in the x plus y is less than or equal to 4. Then I will shade in the x minus 3y is greater than 8. And notice, guys, is the answer to your solution, or the solution to your system, is a region of points. It's where the two shading is going to intersect. And that would be about right here, right? Where you see how the red and the black, or the black and the yellow are intersecting into one point. That would be where my solutions lie. So if I would pick the point -3 or 0, -3, that would work in both of my inequalities. So let's actually put this into practice. So I have x plus y is greater than -3, and -6 plus y is less than 1. So first equation I'm going to use, since it's a nice one, I'm going to use the cover-up method to find my intercepts. So I know my x-intercept is the point -3, 0, right? Because x is equal to -3. If I would cover up the y and just consider this an equal sign, my y would be -3 as well. So this is my ordered pair, -3, 0, and 0, -3. -3, 0, 0, -3. And it looks like it's going to be a dashed line, so I'm going to have to dash my line here. So, right there. There we go. Check my 0, 0 test point. So 0 plus 0, that's 0, is greater than -3. That is in case the fact. So I'm going to shade on this side of my line. Now let's change some color here. I'm going to change to green. Put a little dot by it so I know there's green. Notice, guys, though, that this one's not going to be a nice one for your intercepts. So I'm going to solve for y. So I'm going to add 6x. So y is less than 6x plus 1. Let's graph that. So I got plus 1 for my y-intercept. I'm going to go up 6 over 1. Same thing, down 6 over 1. And it looks like this is also a dashed line. So let's see how well I can do a dashed line today. Little curvy, but not too bad. I'm not sure if the point 0, 0 doesn't work. So I'm actually going to pick a really large number on this side. I'm going to pick the point 10, 0, just because I am not sure if my point right here, I'm not sure if that works. Or I'm not sure if 0, 0 is doesn't cross. So I'm going to pick 10, 0. So -6 times 10 plus 0, it needs to be less than 1. So -16 needs to be less than 1, which is in fact the fact. So I'm going to shade on this side of the line. Now notice, guys, I'm shading on the entire side of the green line because I'm going to be shading on that side. So notice, guys, that my two equations, I'm going to take my highlighter here. Notice that the two equations work up to right here. This is where they meet up, they shade together. Sometimes I like to underline or highlight or color with a different color where they intersect, just so I can find it easier. So these two are where they are intersecting perfectly. Let's try the next example here. So I have 4x plus 2y is greater than or equal to 8, and y is less than -2 times the quantity of x plus 5 plus 7. I'm going to use my intercepts on the green equation. I'm going to color it in green. So my x-intercept will be at 2. My y-intercept looks like it will be at 4, because if I cover up the x here, it'll be 2y is equal to 8. That's 4. So 2, 0, 0, 4, put a dot there. It looks like it's a solid line, so let's go ahead and make a little bit more dots for myself here. Am I going right up 4? Whoop, messed up a little bit. Need to count right. Up 4. 1, 2, 3, 4. Yep, okay. So let's go ahead and connect my dots with a line. Oop, that's a pretty wonky line, but not too bad. There we go. Let's check up 0, 0. So 0 is greater than or equal to 8. That is not the fact, so we are going to shade on this side of my line. Nice and colorful. There we go. Let's go ahead and now use, let's go ahead and blue for the second equation. Notice, guys, this is in translated form, so we need to find the point. -5, 7, because remember your x value was opposite. So -5 and a +7, that would be all the way up here. And then I'm going to use my slope, down 2 over 1, down 2 to the right 1. There we go. And this is going to be a dashed line, so let's go ahead and do my dashed line here. There we go. Now let's see which side I'm going to shade on. Is it going to be this side or that side? So let's plug in 0, 0. So 0 needs to be less than -2 times 0 plus 5 plus 7. Or 0 needs to be less than -2 times 5 plus 7. -10. That'd be -3. So 0 needs to be less than -3. -3 is less than 0. That doesn't work. So 0, 0 doesn't work. Got to shade on this side. So notice, guys. Notice what's happening here. This system doesn't have an intersection. There is not a region of solutions where these two inequalities meet. So technically what this would be is a no solution system of inequalities. They do not intersect. They are parallel lines that do not shade on the same side. There is no region of points located on this graph. And that's the end of this video. See you later, Sabers.